Hey everyone, welcome back. In this example, we're asked to do something a little bit different. Here we're asked to find the center and radius of a circle described by the equation x squared plus y squared plus 4x minus 6y minus 23 is equal to 0. Now normally, finding the center and radius of a circle from the equation of the circle is something we can do almost immediately and read off from the equation, but that's only if our equation is written in that general form for a circle. And remember, our general, or I should say standard form for the equation of a circle is the quantity x minus h squared plus the quantity y minus k squared is equal to our radius r squared. And so the equation of the circle that was given to us was not given to us in this standard form. It looks like the equation we were given started in the standard form, and then maybe this x minus h quantity was expanded along with this y minus k squared quantity. Both those were expanded. Some like terms were combined, and that's how we ended up with the equation that we currently have. So we're trying to undo this process of expanding these binomials squared. So we're going to have to complete the square for our current equation in order to rewrite it in that standard form. And so a quick little review of completing the square. Let's go ahead and do this off to the side over here. Is whenever we have a quantity like x plus a squared or x minus a squared, that binomial squared is always going to expand to either x squared plus or minus 2ax plus a squared, where if we have plus on the left-hand side, we have plus on the right-hand side, and negatives would also correspond to each other. And so we currently think of the equation for our circle as being in something like this expanded form over here on the right-hand side. And we want to factor it or rewrite it as this quantity x plus a squared or x minus a squared, where the a value, depending on whether we're working for x or y, is going to correspond to h and k and help us find the centers of our circle. So I like to do a little bit of preliminary setup before I start completing the square. And what I mean by that is I like to kind of group our x terms together and our y terms together, and then all the constants, get them out of the way, move them to the other side of our equation. So if we do that here, I can rewrite our original equation for our circle that we started with in orange. I'll go ahead and write it in green. It'll look like x squared plus 4x plus some constant. I'm going to leave that blank here, and I'll come back to that in just a second. Let me finish setting the rest of the equation up though. So this is kind of grouping our x terms together. Now we're grouping our y terms together. We have a y squared and a negative 6y. We're going to leave some room for a constant here. And then I'm going to take that negative 23 that was the constant originally in our circle's equation and just move that to the right-hand side. So now our equation is looking like x squared plus 4x plus blank plus y squared minus 6y plus some other blank is equal to 23. And so now these three terms, the x squared plus 4x plus some unknown term, are supposed to look more like the right-hand side of our general x plus a or x minus a squared quantity. And so now what we have to do is kind of figure out what constants do we have to have here on the left-hand side to give us these perfect square trinomials that can factor as some nice binomial squared. And the key to finding that is using these coefficients in front of our linear terms. That is using the 4x and the negative 6y. The 4x is like our 2ax on the right-hand side over here, and our negative 6y is like the negative 6x or negative 6y that we would have on our right-hand side. And so that means these blank spots are supposed to be these constants a squared. So how do we find these a squared numbers? Well, they're related to that coefficient in front of x. If we take that number in front of x, cut it in half, that'll take 2a and turn it into a. And then if we square that number that we just cut in half, we'll get to a squared, the constants that are needed to make these perfect square trinomials so that we can factor them as some binomial squared to eventually get us back to that standard equation for a circle. All right, so we take that number in front of the x, that 4, we cut it in half, that's our 2a, cutting it in half turns it into a, and then we square it, and that gives us a squared. So that's going to be 4 divided by 2 is 2. 2 squared is 4. So the constant that we need to have here on the left-hand side to make x squared plus 4x plus that constant a perfect square trinomial is the constant of 4. Now that'll factor nicely as x plus 2 squared, right? We can always figure out how to factor it just by using that a value we found to help construct that constant. But we have to be careful here because we just added 4 to the left-hand side of our equation. We have to stay balanced here and equal. So whatever we do to one side of our equation, we just have to do it to the other side as well. So that means we also need to add a 4 to the right-hand side at the same time. All right, we're not quite done yet. We've made the x terms a perfect square trinomial. Now we need to repeat this process for our y pieces or y terms, and we're just running through the same motions again. We take the linear coefficient, -6, that is like our 2a. So we have to cut it in half to turn it into just a. Half of -6 is -3. We then have to square that to get our a squared or our constant. -3 squared is +9. So that means we have to add a 9 to our y terms to make them a perfect square trinomial, something we can factor very nicely to get us to our standard form. But we have to also remember we added 9 to the left-hand side. That means we have to add 9 to our right-hand side as well. Now all the hard work is done. Now we just have to do a little bit of factoring and we will get the equation of our circle in that standard form. So like I already mentioned, the x squared plus 4x plus 4 will factor nicely as x plus 2 squared. The y squared minus 6y plus 9 will factor nicely as the quantity y minus 3 squared. And then on the right-hand side, we just have to sum up these numbers. 23 plus 4 is 27, plus 9 is 36. So we get the quantity x plus 2 squared plus the quantity y minus 3 squared is equal to 36. Or we can also think of that 36 as 6 squared. Now we are in that standard form for a circle. So we can just read off the center and the radius from our equation. And so the center is going to be the point, -2, +3, right? They're the values of x and y that make these quantities disappear, or really just always opposite that number next to x and y. So that's a +2. It's going to really be a -2 for the center. And if we have y minus 3, then that -3 is the 3 that is going to be the y coordinate of our center. And so the radius is the last thing we have to find here. That's the square root of 36, or 6 squared. And so we have found the center and radius of the circle described by that equation that was not in our standard form. We completed the square to put it into our standard form, and then we were very quickly able to read the center and radius values.